set. So, good afternoon, sir. I will discuss the pump for PSME code. The general requirements of the pump first is the scope. This standard deals with the selection and installation of pumps supplying water for domestic, industrial, or private and or public for protection. The purpose of this standard is to provide a reasonable degree technical know-how and safety through installation requirements for pumps based on sound engineering principles, test data, and field experience. The pumps other than those specified in these standards and having different design features may be installed when such pumps are listed by a testing laboratory. The unit consisting of pumps, driver, and controller shall perform in compliance with this standard as an entire unit when installed. Installation of pumping equipment to supply buildings from existing water supply should only be allowed if there is always water in the mains to prevent contamination of water system when air gains entrance due to negative pressure created by pumping. A shut-off or block bulb followed by a check bulb shall be placed between the suction of pump. A water tank may be installed above the roof of the building or by separate tower for the purpose. The tank is an unfired pressure vessel initially full of air into which water from mains is pumped. The first classification of pump is centrifugal pump. It is used to transport fluids by a conversion of rotational kinetic energy to the hydrodynamic energy of the fluid. The rotational energy typically comes from an engine or electric motor. They are a subclass of dynamic axisymmetric work-absorbing turbine machinery. These are the classification under the centrifugal pump. The first one is when the kinetic energy is converted to pressure energy by means of the volute shape of the casing, the pumps are called volute centrifugal pumps. The next classification is when the conversion of kinetic energy to the pressure energy occurs in the passage of the fluid through stationary diffuse vanes. The pumps are called diffuser centrifugal pumps. The radial type of impeller is characterized by a rather long narrow passage for the water. The ratio of outside impeller diameter or D sub 2 to impeller eye diameter D sub 1 is approximately number 2. The Francis type of impeller is characterized by wider passage for the water and the ratio of outside impeller diameter to impeller eye diameter is about 1.5. The, cen- uh, the other pa- the other classification of centrifugal pump is the mixed flow type of impeller is characterized by a mixed flow velocity vector which naturally has a horizontal component along the shaft as well as a vertical component perpendicular to the shaft. The ratio of outside to inside is slightly over unity. The next classification of centrifugal pump is the axial or propeller type of impeller has a ratio of outside to inside equal to unity. The pumping action is accomplished by lifting of the water by the pitch of the blades of propeller as it revolves. As this type of impeller has no guidance for the flow of water, it cannot operate with suction lift. The impeller or propeller is generally immersed in the liquid. These are the classification of centrifugal pumps by geometry. The common form of classification of turbo machines and in centrifugal pumps in particular from the shape of casing. The next is the by inlet geometry, commonly applied to turbo machines and rotary pumps to a lesser extent which describe the basic geometry of the section entry of the pump. Next is by layout. It refers to the design position of the pump, shaft access such as horizontal, vertical, or inclined. This indicates the mounting requirements. The next is the by mounting. Generally describes the design method of mounting the pump and applies but not necessarily always specified for all pump types. Next is by operation. Basically is the description of the design duty of the stand by pump like for the example air pump, source pump, standby pump, auxiliary pump, etc. but this does not necessarily follow that the use of such a pump is restricted to the specified operation. Next is by liquid handled. This specific this specific description indicates that the pump can handle a particular type or types of fluid or product like chemicals and other corrosive liquids. The next is by material. This indicates that the type of the pump whose material construction, particularly the wetted parts, is suitable for handling chemically active or corrosive fluids. The next is the by drive. This specifies the method of drive intended or applicable for the pump as spies in the design mounting area limitations or other requirements to use. The last classification of centrifugal pump is submersible pump. Pumps of this type are sufficient importance to warrant a classification of their own, representing the type of pump with an integral electric motor which can be immersed in the product being handled. These are the basic parts of centrifugal pump. The first one is the impeller. It imparts velocity to the liquid resulting from the centrifugal force as the impeller is rotated. Next is the casing. Gives direction to the flow from the impeller and converts this velocity energy into pressure energy, which is usually measured in feet of head. The next is the shaft. It transmits power from the driver to the impeller. Next is the stopping box. This is means of throttling the leakage which would otherwise occur at the point of entry of the shaft into the casing. Next is packing. This is the most common means of throttling the leakage between the inside and the outside of the casing. Next is the gland, is to position and adjust the packing pressure. Next is the seal gauge or also called water seal of lantern ring. Um, it provides passage to the distribute the sealing medium uniformly around the portion of the shaft that passes through the stuffing box. This is very essential when suction leak condition prevail to seal against leakage of air. The next is the mechanical seal. It provides a mechanical sealing arrangement that takes the place of packing. Basically, it has one surface rotating with the shaft and one stationary face. The minute close clearance between these two faces prevents leakage of liquid out of air in. The next is the shaft sleeve. It protects the shaft where it passes through the stopping box. It usually used in pumps with packing but often eliminated if mechanical seal are employed. The next is the wearing rings. It keeps internal recirculation down to a minimum. Having these rings are replaceable wearing surface permits renewal of clearance to keep pump efficiency high. The next pump classification is rotary pumps. It is a positive displacement pump consisting a fixed casing containing gears, cams, screws, vanes, and plungers, or similar elements actuated by rotation of the drive shaft. Um, the The cam and piston pumps, this type consists of an eccentrically bored cam rotated by a shaft concentric in a cylindrical bored casing with an abutment or followers to arrange that with each rotation of the drive shaft has a positive quantity of liquid is displaced from the space between the cam and follow in the pump casing. Next is the gear pumps. This type consists of two or more gears operating in closely fitted casing so arranged that when the gear teeth unmeet on one side, liquid fills the space between the gear teeth and is carried around in the tooth space to the opposite side and displaces the meat as the teeth mesh again. The two types of gear pumps are external gear pumps and internal gear pumps. The external gear pumps have all the gear rotors cut externally. The gears may be square, single helical, or double helical, while the internal gear pumps have one rotor with internally cut gear teeth meshing with an externally cut gear idlers. Pumps of this type are made with or without a crescent-shaped partition. The screw pumps, this type consists of one, two, or three screw rotors so arranged that as the rotors turns, liquid fills the shape between the screw threads and is displaced actually as the rotor thread mesh. The main pump is a type consists of one rotor in a casing machine eccentrically to the drive shaft. The next is the reciprocating pump. It is a positive displacement unit wherein the pumping action is accomplished by the forward and the backward movement of a piston or plunger inside a cylinder usually provided with bulbs. The classification of reciprocating pumps. One is the direct acting steam pumps. This type has a steam cylinder with no lock on valves, a water cylinder, and a common piston rod. As there is no lock, the steam is admitted throughout the length of the stroke, hence the pressure volume diagram of the steam end is rectangle. Yes, sir. Piston, sir. Opo. Opo. Opo, sir. The next is the crank and flywheel reciprocating pump. This type is driven by compound, cross-compound, or triple expansion steam engines. In large sizes, such units are known as pumping engines. The next is the power-driven pumps. This type receives its forward and backward motion of the piston and plunger from the rotary motion of a revolving crankshaft by means of a crank and connecting rod. Reciprocating pumps can be single acting or double acting. They can be simplex, duplex, triplex, or so on, depending on the number of water cylinders on the machine. The accessories of reciprocating pumps one these one. First is the air chamber. Its function is to smoothen the flow due to the nature of flow of the liquid from such type of pump. The size of chamber required depends on the type of pump and generally on the pressure and length of pipeline. Air chamber can be placed either on the suction side or discharge side of the piping installation. The next is pressure relief valve. This will be installed on the discharge side between pump and any other valve. The next is the put valve and strainer. These should also be installed at the end of the suction pipe. The foot valve should be of a size at least equal to the size of the suction pipe. The next is the plunger pumps. In modern plunger pumps are refinement of the old hand pumps that have played such an important role in the country home and small town water supply from wells. A ball valve, plunger, and check valves are used in this pump. In operation, only the plunger moves. The next is the turbine pumps. These pumps represent the application of vertical centrifugal pumps to deep well surveys and are built for heads up to 305 meters and for the capacities up to 26,495 liters per minute. Uh, Next is the ejector centrifugal pump, a type of deep well pump that has come into wide use for small capacities combines a single stage centrifugal pump at the top of the well and an ejector or jet located down in the water. The last one is the air lifts. Another wells is by air lifts with compressed air being admitted to the well to lift water to the surface. For successful operation of the system, the discharge pipe must have its lower end submerged in the well water. The fluid water metrication. If the hydraulic or pneumatic circuitry is designed with metric parameters, equipped and other components such as valves, cylinders, or gauge must have mounting that are compatible with metric fasteners such as bolt and clevis pins. Metric pumps foundation and alignment, pumps should installed properly. A substantial foundation is important in maintaining alignment. The foundation should preferably be made of reinforced concrete. If pumps and drivers were shipped from the factory with both machines mounted on common base plate, they were accurately aligned before shipment. Two forms of misalignment between the pump shop and driver shop. First is the angular misalignment. Next is the parallel misalignment. Supervision of installation, satisfactory of operation of vertical turbine type pumps is dependent to a large extent upon careful and correct installation of the unit. Pump maintenance and servicing. Pumps, like any other machines, requires regular preventive maintenance and servicing.